Okay, so we've talked about distance, which we have said is simply the length between 2 points and it's a scalar quantity. And then we've talked about displacement, which we have said is the shortest distance between 2 points, and we've said this is a vector. We've talked about speed, which I've said is the rate of change of distance with time, and because it doesn't have direction, this is a scalar. And then we've talked about velocity, which I've said is the rate of change of displacement with time, and so it is a vector because it has got direction. Now we are talking about acceleration, which we've said acceleration is the rate of change of velocity with time, and we have said acceleration is given by final velocity minus initial velocity divided by time. So v is meaning final velocity. U means initial velocity. Initial velocity is the velocity that you are starting with. So this is the formula for acceleration. Final velocity minus initial velocity divided by time. For example, if they tell you uh, a person accelerates from rest, and then they say to 2 meters per second in, let's say, 1.5 seconds, find the acceleration. So if you follow this statement well, a person accelerates from rest. So if you take now here, you need to write the final velocity, okay, and then the initial velocity and also the time. So in this case, a person accelerates from rest, meaning that at the beginning they were not moving. So the initial velocity is 0, and then 2 meters per second, meaning that the final velocity is going to be 2 meters per second, and then the time is 1.5 seconds. So to find the acceleration is final velocity minus initial velocity divided by the time. So it's going to be the final velocity. The final velocity, of course, is 2. The initial where we started is 0 over the time. Time, that is 1.5. So 2 divided by 1.5. 1.5, we can also write it as 3 over 2. So this is, we are saying 2 divided by 3 over 2, which we can also write as 2 divided by 3 over 2, or 2 times 2 over 3, like that. So this will give us 4 over 3. Okay. But you'll be allowed to use a calculator, so you don't need to worry with those calculations. So one thing you need to know is the units for velocity, distance, and these other quantities that we've talked about. So if you look at just distance, the symbol we use is S. The SI unit for distance. If you talk of SI unit, it is a system, international system of units. This is the unit that is accepted for you to be used. So the SI unit for distance is meter. So every time you are working with distance, make sure that if they've given you in kilometers, you take it to meters. If they've given you in centimeters, take it to meters. The SI unit for displacement is also in meters. And then the SI unit for speed or velocity. So speed or velocity, we said they've got a symbol of V. Since velocity is given by distance, I'm using V so that you'll be able to follow up. Distance, okay, S over time. And distance, we know that the SI unit for distance is meters. And then the SI unit for time, we always use seconds. So the SI unit therefore for speed or velocity is meter per second. And then when you're talking about acceleration, the symbol for acceleration is A. Remember, acceleration is given by final velocity minus initial velocity over time. So when you subtract final velocity minus initial velocity, you still find velocity. Now, the unit for velocity is meters per second. So on top we have got meters per seconds, and then down we have got time. The unit for time is second. So I can also write this as meter. Instead of me writing per, I'm going to write over seconds. And then instead of me writing this over, I'm going to write divided by seconds. This can also be written as meter over seconds. We can change division symbol into multiplication, meaning that this one which was on top will come down. So we're going to have 1 over second. So we're going to multiply meter times 1, that is going to be a meter. In the denominator we're going to have second times second, that is going to be second squared. So this is the unit for acceleration, meter per second squared. Does this make sense? Okay, good. So we need to know those because they can also bring that. They'll bring different units there to ask us to identify which one is going to be the unit for acceleration. Okay, so let's look at what we call travel graphs. Now the question is, what are travel graphs? So when we are talking about travel graphs, these are simply graphs which represent the distance you are going to cover in a certain period of time, or the velocity you are going to be moving at in a certain period of time. Okay. So when we are talking about travel graphs, we have got uniform travel graphs and non-uniform travel graphs. So we are first going to start with a distance time graph as a first travel graph. So for a distance time graph, the y-axis is going to have distance. The x-axis is going to have time. So we're going to have a lot of scenarios. Let me make this a bit smaller. Let me make 4 scenarios so that we understand them well. Okay, so the x-axis is always time. We need to know that. And then since this is a distance time graph, meaning that the y-axis is going to be distance. Okay, we have got distance there. It is very important for you to label the graph. Now, if you have got a travel graph, a distance time graph, you only have a line like this. You need to know the meaning. What does it mean if you just have a straight line? Maybe let's say here it is 20 meters. What does it mean? Okay. So when you see this kind of graph where you just have a straight line like this, you can see that here maybe if it is 0 seconds, here it's going to be maybe 20 seconds. The time is in the SI unit of seconds. So time is moving, but see the distance, you are still on the same level. The distance is not moving, but time is what? Time is moving. So for this kind of graph, it means that a person is not moving. That's the interpretation. Because you are not moving, that means there is no or zero acceleration. Remember, for you to have acceleration, you need to have speed over time. But if you don't have movement, then there is no speed. Because speed has to do with what? With movement. Okay. So this means there is no acceleration or there is no movement. And then you can have something like this. So if you look at this one, you can see this is a straight line and it is constant. I haven't drawn it like this. It's a straight line like that. So when you see such a line, if you find, for example, you are going to get maybe this point. Let's say this is point A, and let's say we have got a point B there. So maybe let's say at point B it is 20, at point A it is 10. This is distance. It is reading in what? In meters. And then let's say here it was giving you 5 seconds. Here it is giving you 10 seconds. So you can find the speed. Speed is given by distance over time. So in this case, distance, you need to find the change. So you can see that the final distance is 20. You started at 10. So the distance is going to be the final, which is 20 minus what you started with, which is 10. So the distance is going to be 20 minus 10. And then over the time, it is a final time where you are minus the time that you started at. So it will be 10 minus 5. So on top, 20 minus 10 is 10. Down 5, 10 minus 5 is a 5. So this is going to give you 2. The unit is going to be distances in meters. Time is in seconds. So it is going to be 2 meters per second. So this line represents constant, okay, constant speed or constant velocity. That is what the distance time graph represents if you have got a straight line like this. Is that okay, or you've got a question there? Okay, good. So we should know that that's constant speed. All right, and you need to know that always the distance at on top is bigger than the distance down. You can see that this is 20, but this one is 10. Okay, let's look at the other one. Let's say you have got a graph which is looking like this. So this is a non-uniform graph. You can see that it's changing like that. It's not a straight line. For this graph, this, if you check the way it is going like this, if you just get any 2 points, for example, here, and let's say also at this point. So this one, you can get maybe the distance there is reading, let's say 20, and then the distance here is reading, let's say 5. So this region you are able to see at this point is not representing, for this one we said it's representing constant speed, but this one is representing not constant speed but increasing speed. Okay, that is increasing speed, meaning that maybe if you are running maybe let's say 5 steps in 1 minute, you will now be running 7 steps in the next minute, and then 10 steps in the next minute, 15 steps in the next minute. So you are increasing the speed. You are not moving at constant speed. For this one, if you are moving at 10 meters, maybe 2 steps in 5 seconds, then you continue moving like 2 steps in 5 seconds, 2 steps in 5 seconds, like that. That's why we're saying this is representing constant speed. Okay, it's different from here, it is increasing speed. And then you also have when your graph is looking like this. So because this is increasing speed, whenever speed is increasing, then you are going to have acceleration. So you are going to, in this case, have a what? A constant acceleration. Now for this one, whenever you have got constant speed, you need to know this. When you have got constant speed, remember acceleration is given by final velocity minus initial velocity over time. So if the velocity is constant, meaning that final is going to be the same as the initial. So final minus initial, if the same thing, for example, if the final velocity is 2, the initial velocity is also 2. 2 minus 2 is going to give you 0. So on top we are going to have 0 over, the time can be even 5 seconds. So 0 over any number is still 0. So for this graph, when you have got constant speed, it means you have got no acceleration. So this region represents no acceleration. But for this other one, where you have got increasing speed, you have got constant acceleration or increasing acceleration, depending on the way the graph is. When you look at this one, whenever the line is going like this, it means you are reducing. So for this one, this line is going to represent decreasing speed. So because the speed is decreasing, like you were increasing very fast here, you've started reducing like that. Since the speed is reducing, then there's also a deceleration. Deceleration, the other word we can use is retardation. So when you're talking about retardation, is simply reducing in acceleration, meaning that you are reducing. That's the meaning of deceleration. Acceleration means you are increasing, but deceleration means you are reducing. Okay, so this is for a distance time graph. This is what you need to know. Okay, let's look at a velocity time graph. So when we're talking about a velocity time graph, I'm also going to draw four scenarios. So the x-axis always represents time for any graph. Now because this is a velocity time graph, so this is going to represent velocity, the y-axis. Now when you have got uh, a line just like this, you can see it's down there. It's just on the x-axis. This represents that time is moving, like time is moving, but you don't have any velocity. You don't have any velocity. So this means that something is not moving. No movement. If there's no movement, then there's no acceleration, and there's no distance covered in this case because something is just on the same position. And then if you see a line like this, this is going to represent, let's say here it is 20 meters per second. That's the velocity. So this line, because this is a velocity time graph, this is going to represent constant velocity. Why is it constant velocity? You can see that we are just moving at the same velocity, the velocity of 20 meters per second. So this means that something is moving, but it is moving at a constant velocity. Maybe if you are covering 5 steps in 1 second, you continue covering 5 steps in 1 second, like that. So it is constant velocity. So whenever you've got constant velocity, then you have got no acceleration. Every time you've got constant velocity, you have got zero acceleration in linear motion. You can also have a graph which is going like this. Okay, now let me put it like this. So this point you are able to see here, because this is a velocity time graph, this is going to represent constant acceleration because velocity is changing. So that's why that is constant acceleration. This point is constant speed, is just this line. It's constant speed, meaning there's no acceleration. And then this one, you can see that we are reducing. Whenever you see a line that is going like this, even if it is like this or like this, just know that there is reducing. But if you see like a line like this or like this, just know that there is increasing. So this is representing constant deceleration. That's constant deceleration. So to decelerate means to reduce in speed. Is that okay? Okay, so you can also see something like this. You can see something like that. So if you see at this point, the line is looking like this. So this point we have got increasing speed. Okay, we have got increasing speed at this point. You can see that the line is going like that, or increasing rate. We can also say rate. But if you look at this point here, we have got a line that is looking like this. So we have got a decreasing rate. So these are some of the things that you should be able to know when you're talking about travel graphs. You need to understand this because they can give you a graph in an exam and then they ask you to interpret what it means. So again, just from here, you need to understand what we call equations of motion, because we're talking about linear motion. So on the equations of motion, the first equation that you should know is acceleration is final velocity minus initial velocity over time. So for this equation, I'm going to say acceleration is over 1. I'll multiply 1 times this. So we're going to get v minus u. And that is going to be equal to, I'll multiply a times t. That is going to be at. And then this u is negative. I'm going to take it the other side of the equation. So it's going to become v is equal to, it becomes positive u because it was negative, and then plus at. So this is an equation that you should know. This is the first equation that you should know. And then the other equation that you should have in your mind is distance is given by initial speed times time plus half, okay, plus half gt squared. Or we'll not use g, we'll use a, acceleration. If we use g is acceleration when something is falling, but this is linear motion. This is the second equation you need to know. And then the last one you need to know is final velocity squared is given by initial velocity squared plus 2 acceleration times time, times distance. So these three equations are very, very important when you're talking about linear motion. So let's say a person goes to rest from, let's say, 20 meters per second in 5 seconds. Calculate the first question, let's say the deceleration, and then the second question is the distance. Okay, so let's work this. So from what you've been given, a person goes to rest. If you go to rest, meaning that the final velocity you are going to have is 0. And then it goes to rest from, meaning that this person, the initial velocity started with is 20. And then they've given us the time is 5 seconds. So we want to find out the deceleration. So to find the deceleration, you can use this equation or this equation. but mostly we're going to be using this one. V is equal to u plus at. So the final velocity, you can see the final velocity which is being given is 0 because it goes to rest, and then the initial velocity is 20, and then plus acceleration we don't know, times time, the time is 5. So I'm going to take this 20 the other side, so it's going to become negative 20, and that is going to be equal to a times 5, that is going to be 5a. So divide both sides by 5. So acceleration is going to give you 5 into negative 20, that would be negative 4. Remember the unit for acceleration, meters per second squared. But the question is saying find the deceleration, not the acceleration. So whenever you see a negative in front of acceleration, that means it is deceleration or retardation. So to give the final answer, you're going to say therefore deceleration is equal to, so you now write a positive answer, positive 4 meters per second. So just a positive, just the word deceleration means that the answer you found was negative. So if you say deceleration, you don't need to put that negative. But if you say acceleration, you can put the negative because it means you are reducing in speed. So that is going to be the answer for that one. Is it okay? Okay. And then the next one is asking us to find the distance. So to be able to find the distance, you can use this one or this one, depending with the one you want. Since we know the initial velocity, we know the time, we know also the acceleration. Which one should we use? 2 or 3? Okay. So distance is equal to initial velocity times time plus half at squared. So we're going to say u, that is the initial speed. We can see u is 20, and then time is 5, plus half a, that's the acceleration. We have found what? Negative 4. Don't write positive 4, it's negative 4 because it is deceleration. And then time is still 5, but we square the 5. So this is going to be 20 times 5, which is 100. And then 2 can go into 4, that is going to be 2 times. But remember, that's a negative 4. So 2 into negative 4, that will be negative 2. And then 5 squared, that is a 25. So from here we've got 100 minus 2 into 20, 2 times 25, that is going to be a what? A 50. So I've got 100 minus 50, which is just a 50 meters. So this is the distance which was covered, 50 meters. We are good? Do you have a question? Okay, let's see some questions. We see if we can answer. So we have been given this question here. I hope you are able to see. Are you able to see it well? Okay. A body moving from rest acquires a velocity of 20 meters per second in 4 seconds. It moves with this velocity for 6 seconds and again accelerates to 30 meters per second in 5 seconds. It travels for 3 seconds at this velocity and then comes to rest with uniform retardation in 10 seconds. Draw a velocity time graph and use it to calculate. Okay, so before even reading us down, first draw a velocity time graph. So I'm going to put this. So this side we have got time, and then this side we have got velocity. Okay, we're going to start. So this position is 0, this one. Velocity and time, they are all 0. So we'll start. A body moving from rest acquires a velocity of 20 meters per second. So we've been told it acquires a velocity of 20 meters per second in what? In 4 seconds. So let's say 4 seconds is here. So this person is going to come to 20 in 4 seconds. They are moving from rest, so we're going to have a straight line like that. That's the first statement up to here. And then from there we've been told it moves with this velocity for 6 seconds, meaning that it will continue moving with 20 at 20 meters per second for 6 seconds. So for 6 seconds, if you are at 4 seconds and then you move for 6 seconds, what time are you going to take? Or what time are you going to reach to finish the 6 seconds if you are starting at 4? You are starting at 4 seconds and then you are taking 6 seconds. What time are you going to stop your journey? So you are going to stop at 10. So because you are already at 4 and then for 6 seconds you are moving with the same velocity. So we're going to stop at 10. So at 10 here, that's how we're going to move like that. So from 4 to 10, that is for 6 seconds we've been told here, we are moving with constant velocity. That's what we said, constant velocity is a straight line. And then from there, it again accelerates to 30 meters per second in 5 seconds. So we're accelerating in 5 seconds, but we are already at 10. But we're accelerating in 5 seconds. So from 10, if we accelerate in 5 seconds, at what time are we going to reach? At what time? So that will be at 15. So we're already at 10, and then in 5 seconds we accelerate to 30. So we're going to go up to 30 in 5 seconds. So by the time we reach 15 here, we're going to go up to 30 there. Like that. And then it travels for 3 seconds at this velocity and then comes to rest. So it continues traveling at 30 for 3 seconds. So 15 plus 3, that is going to give us 18. So it will be traveling to 18 at the same velocity. Like that. Okay, from there we've been told, and then it comes to rest with a retardation in 10 seconds. So we are at 18, but we got to rest in 10 seconds. So 18 plus 10, that is going to give us 28. This is when we are going to go to rest. So that's when it is going to drop, going like that up to the bottom. So we have drawn the velocity time graph. Have you gotten it? Okay. Now, let's answer now the other questions. So the acceleration for part A, the question is saying calculate the acceleration where the velocity changes from 0 to 20. So we know that acceleration is given by final velocity minus initial velocity over time. This is part A. So when the acceleration is changing from 0 to 20, so from 0 to 20, meaning that the final velocity is 20, the initial velocity is 0. And then what time did we take? We took 4 seconds to move from 0 to 20. So 20 minus 0 is 20 over 4. That is going to give us 5 meters per second squared. And then for part B, the acceleration y changes from 20 to 30. So this one here, from 20 to 30 is this region. So acceleration is still going to be final minus initial over time. The final, you see, we are going to 30, and then we are starting at 20, and then divided by the time. So the time we took, we moved from 10 to 15. So 15 minus 10, that is 5. 30 minus 20, that's 10 over 5. That is going to be 2 meters per second squared. And then for part C, the retardation. So whenever you're talking about retardation, you look for a point when the graph is looking like this. So that's where we have retardation. So retardation, we are talking about this region which is here. So we're going to acceleration is final velocity minus initial velocity over time. This is where we've reached at this point. We can see that the velocity at 0, that's the final, minus the initial, that the velocity will start, divided by the time. The time we have taken from 18 up to 20. 0 minus